All right, angle relations in polygons, day 1. All right, so a polygon is a closed figure formed by 3 or more line segments. So starting with the triangle, the square, the pentagon, the heptagon, hexagon, octagon, all of those shapes. Those are all polygons. And with our polygons, we start with regular polygons, all right? Regular polygons are equilateral. This literally means that all the sides are the same length, and equiangular. That means all the angles have the same measure. Equi meaning equal, lateral is sides. Equi meaning equal, and angular means angles. And if they have this all the same side lengths, they should have all the same angles as well. It should be a given. All right, so we're going to use a formula. And we're going to start with a simple formula. We're going to use it, and we're going to build on it, okay? So this formula is based on a mathematical principle that any polygon, you can go from one corner of the polygon, and you can split that polygon into triangles. And the number of triangles is standard. So you count your number of sides, and you subtract 2 from it, and that's the number of triangles you can make. So you got a square, it has 4 sides, you can break it into 2 triangles, okay? And then we know the area of a triangle is 180 degrees. So that gives us our formula. In our formula, which is right here, okay, S equals n minus 2 times 180. S, that is the sum of all the angles inside that polygon, and n is the number of sides of your polygon, okay? So we are going to, and it's standard across all of the shapes, whether it's like, if you're talking about squares, whether it's a big square or a small square, the sum of all the angles in that square and the number of sides is going to remain the same. All right, so example 1, 99% of my students are going to get this part. Okay, so example 1, we're going to find the interior angle sum. We're going to find S, basic, okay? S equals the sum, n equals the number of sides. So it says find the sum of the measure of the interior angles of a decagon. Okay, a decagon, deca means 10. So n is going to be 10. Deca, like a decade, is 10. A decagon is a 10-sided shape. Okay. So our equation is going to be S equals n minus 2 times 180. So the sum of all the angles of this decagon equals the number of sides, which is 10, minus 2, because this is how many triangles we can make inside of a decagon, and multiply it times 180. So the sum of all the sides equals 8 times 180. Calculator will be your friend with this unit section. And so S equals 1,440. Okay, 1,440 degrees. That is the sum of all of the angles in a decagon or a 10-sided shape. Okay, we said 99% of my students are going to find this. Okay, but we're going to build on it, and we're going to move on. Okay, so let's look at the back. On the back, it wants us to find the measure of each interior angle. So we found the measure of all of the angles. So now we're going to find the measure of each angle. Okay, so we are going to find the measure of an interior angle of a regular hexagon. A hexagon is a 6-sided shape. So hexa equals 6. So n equals 6. All right. Who came up with these names? I don't know. It wasn't me. But n equals 6. All right. Hex, oh, here we go. Hex is 6. So this hexagon is a polygon with 6 sides. Okay. So we're going to find the sum of the measure of all the angles first. So again, the sum of all the angles equals the number of angles minus 2, because that's how many triangles you can draw inside of that hexagon, and then times 180. So S equals 6, because that's what n equals, minus 2, times 180. The sum of all the angles is 4 times 180. Calculator's your friend. S equals 720. So that's the sum of all of the angles. So all 6 angles equals 720. But we want to find the measure of one interior angle. So for that step, we are going to divide the sum by the number of angles. Right, here's the cool thing. Okay, so you're going to divide the sum of all angles, okay, that's S, and you're going to divide that by the end, by n, which is your number of sides, which you already know. Because guess what? The number of sides is also the number of angles. All right? So you're going to take your S that you found and you're going to divide it by your n, which you also know. Okay? So you're taking your S and divide it by your n. So you're taking the sum of all of the angles and you're going to divide it by your number of sides or the number of angles. They're both the same number. Okay? And to save yourself some steps with the calculator, just leave that 720 in there, and then we're dividing by 6. Okay, and that equals 120. So one angle in a hexagon is 120. It doesn't matter if it's a big hexagon or a little hexagon. If it is a regular polygon, meaning all the sides and all are the same length, that means all the angles are going to be the same length, and each angle is going to be 120. Okay, so about 75% of my students are going to get this far and really understand this concept. They're going to be find the S, and then they're going to be take the S and divide it by the number of sides or angles and figure out the measure of one angle. Okay, so we're going to build, and this is where things we're going to start going sideways for many students, but it's just building on what we've already done. Okay. So example 3, we're going to use the interior angle sum. So we're going to use this information. And what are we going to do with it? Well, first we're going to find the measure of each interior angle. Okay? Just example 2. You find the sum of all the angles, then you divide it by the number of angles. Okay? So that's the first step. Then we're going to find the value of x. All right, let's find the value of x. All right, so let's see. It says it's an octagon, but anytime I see a shape, I start numbering sides. 1, 2, 3, 4, 5, 6, 7, 8. I start numbering sides just because 1, sometimes I might not read what it is, or 2, sometimes it doesn't tell you what it is, and visually you may miss a side, which happens quite a bit. So it is an octagon. It does have 8 sides, so n equals 8. Okay. So again, we're going to find the measure of each interior angle. In order to do that, we're going to find the measure of all the angles first. Okay, so the sum of all the angles equals the n minus 2. That's how many triangles we can draw inside. Multiplied by 180. So S equals, my n is 8 minus 2 times 180. S equals 6 times 180. Okay. Again, your calculator is your best friend. 6 times 180 is 1,080. Okay. This is the sum of all of the angles inside of this octagon. Now we're going to divide the sum by the number of angles. Again, we're going to divide the sum by the number of angles. Important step. Okay. So we're going to take our s and divide it by n. So we're going to take our s, which is our sum, and we're going to divide it by n because the number of sides is also the number of angles. So we're going to take that, again, leave that 1080 in your calculator and divide by 8. Okay. So if you have that 1080 in your calculator, then you just hit divide by 8, and that means each individual angle inside this octagon measures 135 degrees. Okay? This is what we've done so far. We found S, which is the sum of all of the angles inside of our octagon, and then we found the measure of one angle inside of our octagon, and now we're going to use this. We're going to use this 135 degrees to solve for x, because we have this little equation in one of our angles. So let's find x. So for x plus 30, because that is what's written inside of one angle, and we know that that angle equals 135. So whatever you see inside of the angle, write it as is and set it equal to the measure of one angle. And you've created a two-step equation. Told you, everything always comes down to a two-step equation. So circle of isolation, subtract 30 from both sides. For x equals 105. Last step, divide by 4. X equals 26.25. So x in this case equals 26.25. All right. Your assignment. Okay? Your assignment today. All right, your assignment. First off, the first three, 1, 2, and 3, are like example 1 on the front. Example 1, we are finding the sum of all of their angles. Now to let you know, a nonagon, this is a 9-sided shape. And then they just gave up on naming it for us, and they just told us 12 gon and 18 gon. That's n equals 12, n equals 18. But remember, a nonagon, okay, it starts with an n, 9, okay, so n equals 9 in this case. 4, 5, and 6, we're going to find the measure of each interior angle to follow the regular polygons. Okay, remember, these are regular polygons. So those are going to be like example 2. You're going to find your s, then you're going to take your s and divide it by the number of ends. Okay, so we're building. Okay, and then our last two are like example 3. We're going to first find the sum of all of these angles divided by the number of angles, or the number of sides. Find out what one angle equals, which is what you've done in steps 1 and 2. And then set this equal to whatever the measure of one angle is. And remember, this is 1, 2, 3, 4, 5. This is a pentagon. This one, number your sides. 1, 2, 3, 4, 5, 6, 7. This is a heptagon. A heptagon is 7. It's kind of like September, except with an H. A heptagon is 7 sides. So count this one out very carefully, okay? Because if not, this is why, this shape right here is why I number. All right, good luck.